All right, guys, so we're going to discuss this matter, how technical debt impacts business nowadays. So let's start with the basics, maybe. How would you define technical debt? It sounds interesting. It's sort of like a keyword from business jargon, but that in financial terms is a little bit ambiguous. It's not fun to be indebted, but it's good to have some capital borrowed for some productive use, to buy an apartment, to build a factory, etc. It's a burden, but it's also a tool. What about the technical angle, technical debt? David, what's your take?
Yeah. So first, technical debt is a overall term. So I think many times there was a phrase, I think in the 1990s, coined technical debt, but it was kind of also added to that of something that we call credit card, or analogy or metaphor called a credit card. And the idea is that you have a debt, which means I pay something, or I use a card to buy something, and then I have to pay for it later. And so this kind of carried over to engineering or software, and I know this is probably an exciting topic for many of the people here. But when you're building something in software, sometimes you have to make some shortcuts, or you have to make you're like, hey, I'm releasing this software. I don't have a lot of time. I need to get to the market to make sure that my customers are happy. And then there's times when you're like, okay, I have to make some decisions where maybe it's not the best code that I'm writing, or it's not the best architectural design, and then from there, you have to come back and pay for that later at some point. So this is a high level, but there's other aspects, and I'll quickly just mention before I turn it over to the gentleman with me. There's also other areas of debt that we never really talk about, like documentation debt, which is one of my big pet peeves. If something is not documented, now later you have to use your engineering resources to come by and fix this, or document it, because they don't understand how this works, and it takes time to look into that. So this is high level. So you have code debt, you have architectural design debt, you have documentation debt, you also have upgrading of services, like I need now the latest version of SAP as an example for the back office systems, or maybe I need security patches or something like that. But I want to make sure I don't take everything from
cover everything, yeah.
Yeah.
Yeah. So maybe let me take over if that's fine with you. So I would just totally agree with David, but then again, I would also say that actually normally in IT, I don't think that we use that much the term technical debt. I mean, when we are discussing among each other, normally I would say that the term, which is pretty old, as David said, was a bit coined to discuss with business, to discuss with the board, because it gives you this certain flavor or what it is. So you can say that it is something not really nice, that probably you will need to pay for that in the future, and probably it can grow.
Microphone closer.
Yeah, sorry. Probably it can grow. Should I repeat? No,
it's fine. It's fine.
So there's one thing. The second thing I would like to mention right from the start is that a lot of what is discussed during today's panels, but actually also in the past, was a really a bit more appealing stuff, like cloud, like AI, like internet, and all those three-letter abbreviations like TTT, etc. And technical debt, I would say it's a bit more on the other side of the story. So it's not. I mean, this is the term that we are using for many years right now, and it's more about the cleaning the house. So as David mentioned, sometimes we are introducing that on purpose, but then again, this is cleaning the house. So I mean, we are discussing a bit of a tale that is just behind us, and this is the technical debt that we need to pay back in the future. And one more thing, just before I will switch to Marcin. if you will think about it, I mean, from your perspective as users, probably all of you are using, I know, Mac OS or Windows, and none of you right now, for example, is using Windows XP. I mean, I would presume. If you would still use it, then probably you would see what does it mean to have a technical debt, really. And this is the same happens in the IT organizations. I mean, normally your IT organizations, when they are developing code, they are using a lot of frameworks. I mean, normally a programmer doesn't build everything from the scratch. He's using a lot of frameworks, and those frameworks, those libraries, those components are getting old, and you simply need to replace them. So Marcin, I would just...
Yeah, hello, good afternoon. Thank you for the invitation. I would like to add that I've seen many systems with technical debt, and I've been trying to find the root cause of the technical debt in many times. The root cause is the lack of domain knowledge. You know, we are trying to solve the problem without knowing the domain of the business. And we are designing something without proper analysis of the problem. And after the bad analysis, you know, the technical debt occurs in the design, after that in the development, and so on, so on. So the most important thing is to know the domain and to answer the question, what kind of problems you would like to solve with the IT systems? Yeah? After then, probably we'll do good analysis and good design and development.
Is it a trap? Can it be a trap? I mean, to be in technical debt, can it be a trap for a business or for the organization? Or is it advisable or reasonable to stay in some level of technical, how to call it, indebtedness in order to gradually improve your software, introduce new technologies by tests and by try and fail attitude, etc., having this level of technical debt. I mean, using older technologies in order to be ready to implement the new one. How do you cope with that issue in Allegro while you are servicing millions of clients online, live, globally in this very second? How do you cope with that?
Yeah, so all right, so Allegro may be unique. I'm new to many of the companies here, but so we have an architecture that's all microservices. And so this highly distributed system, you know, we have over 3,000 microservices. And with this highly distributed system, what this means is we live with technical debt every day. So it's not a bad thing. You just have to understand how to handle it. And what I mean by this is, you know, again, if we use this metaphor of, you know, financial debt, it's the same thing. You have to know when to use your credit. You have to know when to take a loan out. So in every one of these groups and these microservices, we have product management, we have tech teams, we have stakeholders, either commercial, traffic teams, and we're constantly looking at ROIs, return on investment. Okay, when does it make sense to start paying back this debt? And at some point, I need to really also, I'm hoping we can talk about how to do that, because I think this is extremely important, because many people don't understand how that works. But in all of these groups, you have to, you know, they're constantly making the decision. Do we need to cut corners? Do we not? Do we? And I was just talking backstage. There's a pain threshold as well. How long before? You know, can I have a service that's having problems? I'm seeing the ticket counts going up, or you know, I'm seeing that there's some problems there. When do I start? When do I have to refactor? Excuse me. Or when do I have to, you know, upgrade to a new version of, you know, something, depending on if it's off-the-shelf software or not. So it was a really long answer to say, you know, technical debt is not bad. You just have to understand how to use it, when to use it, and understand that, you know, if you're not careful, it will create a lot of problems in your company. But I'm hoping we get to the point where I can also then tell you how to solve that problem.
If I may follow, you know, from my perspective, it depends on the product stage. At the early beginning of the product, we are accepting many times the technical debt to create some proof of concept and to validate the ideas. But when the product grows and goes on the production, then we have to handle somehow more mature the risk of the technical debt impact on business. Yeah?
Yes, yeah. So go ahead before I...
Just to add to that, because that's really interesting perspective what Marcin is saying, because Marcin is kind of representing more of the security side perspective of IT, and we are here actually more of a, let's say, operational development side. And normally I would say that if, I mean, David's saying that a bit of a technical debt properly managed, let's say, is fine, then I would say that not from the perspective of the security I would expect this kind of answer, because because then, I mean, technical debt normally means that you have, for example, vulnerabilities in your code. For example, this is one of the perspectives of the faces of the technical debt, because it means that maybe when the time comes, you will not be able to cover that. So actually, you're exposing yourself to certain security risks, to maybe even quite huge security risk. And Marcin, you were also saying about not understanding the business, the design, domain. Yeah, but then again, these are probably two different topics. So if you do it deliberately, as David said, that's fine. But then again, if you do not understand design, but maybe the design will change in the future. So maybe right now we are designing for one purpose, and then with time, everything is moving. I mean, we are changing. We need to be agile. That is why we need to have this proof of concept solutions. But then again, everything is changes, which means that that will be growing. And at some point of time, the applications that we have will not be satisfactory for the new needs that may come up.
Yeah, I would like to put a light on the security factor, because I'm from the security focus oriented business from Asseco, responsible for research and development of the trust services, cyber services, protecting transactions. And we are playing with security in terms of operational technical debt and strategic technical debt. And when it comes to strategic, we have to be aware of the risk that will come in the future. Within 7 years, for example, quantum computers that can broke the algorithms. And looking at this problem, we have to prepare the systems to, for example, achieve cryptographic agility. And that's the design principle we should address right now, not waiting for the 2030, so.
For quantum to conquer all our passwords, etc., right? Is that correct?
Yeah, that's a problem. Right now it's only the risk, but the likelihood, probability that the quantum computers will break the current crypto algorithms is still growing. Yeah, I would say exponentially. So we have to prepare our systems to migrate to the algorithms that will be safe,
Yeah. So I'll just add to this. Yeah, so when you're first designing your systems, absolutely, you have domain knowledge, you have your product management, you have your, hopefully, principal engineers, you have your senior engineers there, you're mapping out what needs to happen. But somewhere along the line, which I think you were mentioning, is either your business changes or usually the most common case is scalability. So now, I was first doing 100,000 transactions, now I'm at 10 million, and I'm seeing problems, as an example. And this is where I want to introduce this concept, what I call operational excellence. Operational excellence is the key for you to figure out that, hey, I'm going to have a debt problem that I need to take care of in the future. And what operational excellence is it's so important. In fact, this is probably the first thing that I started introducing at Allegro was, what is the health of our systems? What's happening? How many tickets are we have? Are we seeing loads? What's the CPU utilization that's happening? And when you start seeing these problems, these are indicators. You should probably have alarms. And these are indicators that tell you that, hey, guess what? I have a service that's probably having a problem. And I can name, like five of them right now where I'm seeing these problems. And this is indicators to us that, hey, we have to now fix this. And we now need to schedule it. And this is the last piece, which is how do you fix these things? So I don't know if you want to go into it, but I think you had some more questions.
I wanted to ask you about, this buzzword, this hype over AI. Do you have to go into this direction, not to be technically indebted, or what are your impressions on that? Is it the future, or is it just is there a risk of just a hype?
So should
Andrzej,
I
what's
start?
your take? Because we discussed it.
How much time do we have? So guys, are you bored already? Just
2-3 minutes. I'm sorry.
For, 5 minutes more. So yeah, I mean, basically, you can understand that AI and technical debt, I mean, probably they do not go along that well. This is a bit of a, I would say, different concept. But then again, the question is, should the companies right now, should every company right now go out there and look out for the AI possibilities? And probably the answer is yes. On the contrary, but as you said, in IT for last 20, 30 years or even longer, probably we see that every half a year you have a new hype, new fad. Every now and then there is a new thing that's just popping up, and you need to actually, that's the next best thing, next best app, I don't know, whatever. But and actually AI might just be that way, that thing. So maybe that will be a game changer. So for AI, I would say that you need to be observant, you need to be mindful. But then again, I would say that when you're discussing the technical debt, not to go sideways from the topic. If we are discussing technical debt, I don't think that you should anticipate that much, and I don't think that because I would say that you can overdo it. I mean, if you are getting rid of technical debt and you are, let's say, thinking, okay, so there will be a new thing that will be coming up, so I will implement that right away in my system, then it might go really sideways. We had this, we had this project some time back when we were developing an application, that was a web application. And at some point of time, somebody said, look, guys, but actually we will have a new protocol that is coming, and this application needs to be able to speak this protocol. And protocol is like the language. So this is like the language that two systems are discussing, talking. And the question is right now, is it worth to learn a new language? I mean, in general, when it is worth? And it is worth only when a lot of people are talking this language, then it is worth to learn it. If you are the only one that talks this language, that speaks this language, then it's not worth. So what happened was that we were kind of, let's say, forced to implement this new protocol. We did, but there was a ramifications, there was a bit of consequence that the project got delayed by 2 months, which means obviously cost, means time, which is really important. And then it turned out after a while that actually there was the version of the protocol that we used was 0.3. version, and the one that was released was 1.2 after, a year or so. And it turned out that the new version is totally different than the previous one. So actually we lost those 2 months. Back then we thought that there is a good reason to do that, but it turned out to be actually not that beneficial. So I would say, getting back to the technical debt, that maybe you should just, wait and see what is happening. As David said, you need to be systematic, you need to be disciplined, you need to stay up to date with all your components for the security reasons. But then again, I don't think that you should overdo and actually start implementing everything that is out there.
With regard to AI, I would say that AI brings of course, the supporting of software development by AI brings technical debt by design, because AI is trained mostly on the open source code, which is, let's say, not perfect. It may be also, from the security point of view, poisoned. So we may bring some code which is not, let's say, perfect, but we have to handle it, and we can pay off, of course, this debt. But we should be aware that we have to, control these tools,
All right, gentlemen, I'm afraid we are close to getting into time debt, if there's such a thing. I'm afraid there's no time debt, because we cannot pay back the time. It's this resource that we are incapable of expanding. But it was such a pleasure talking to you. Ladies and gentlemen, David Roberts, Allegro. Please give him a round of applause. Andrzej Piotrowicz, BCG Platinion, and Marcin Szulga, Asseco Poland. Thank you so much for this meeting.
Thank you.
Take care. All the best.
Thanks.